Our final presentation today is Accessibility Standards for Equity in Transportation Planning and Policy by Bruno Dos Santos from McMaster University. Bruno, over to you.
Hello, everyone. Amir, just to confirm, can you see my slides?
We can see your slides, but we can see also the right panel of the notes.
Oh, okay, just a minute. I see. That's good.
Yeah, that's perfect. Right.
Okay, thank you. Um, well, the title of my, first of all, I'm Bruno Dos Santos. I am a PhD candidate at McMaster University under the supervision of Dr. Antonio Paes. The title of my presentation is Accessibility Standards for Equity in Transportation Planning and Policy. During the day, we briefly discuss the importance of accessibility. And as Bren explained, we still have difficulties in defining sufficient levels of accessibility. And when we discuss about standards in transportation, or more specifically, when we define a equity standard, we are also defining the level of fairness to be achieved and the acceptable degree of inequality. Usually, accessibility standard will combine a concept of fairness with a threshold criterion. In terms of fairness, this approach is guided by three moral principles. So the first one is actually the understanding of accessibility as something essential for a dignified life. The second one is the understanding that a fair transportation system provides sufficient accessibility to all individuals. And the third is that sufficient accessibility levels should be defined based on the needs of the most equity deserving population groups in order to reduce the inequalities of opportunities. Based on this, the objective of this research was to propose equity standards for transportation planning based on the relationship between calculated job accessibility and people's perceptions of employment reachability. In terms of methodology, we use the data from the census of population to calculate accessibility models, and we added to these models individual level variables obtained from the National Survey on Transport Poverty to estimate regression models, and then we identify equity standards, we measure equity, and we also identify priority areas for policy intervention. Important to say that we organized the census of population in our package to provide land use tables and also calibrated impedance functions to calculate accessibility models at the census tract level for any census metropolitan area or census agglomeration. In terms of study area, it refers to the Greater Toronto and Hamilton area, more specifically to the 25 census subdivisions within Toronto or Hamilton census metropolitan area. According to the last census, in this area resides more than 7.2 million people. And we use the input from the data, or the input from the census to calculate accessibility models, in which we use the 3.8 million people in the labor force and the 3 million jobs opportunities that is distributed in a study area. We also calibrated impedance functions to represent people travels behavior. And we also calculated the travel times between the spatial units using the R5R. We use a multimodal spatial availability per person. That is simply the number of jobs that is possible to reach by a transportation mode divided by the number of people actually taking the mode. This measure is competitive, is constrained, and we calculated for three modes. So we are considered active as the sum of the jobs that are accessible by walking or cycling. We also have motorized and public transit. And the analysis was realized using the census tract as the spatial unit. Here we can see the result of the multimodal spatial availability per person. We have the number of jobs reachable by each person taking the mode, varying from 0 to 2 jobs per person. One thing that we can see is that the motorized accessibility is the highest between the other between the modes. We see as well that it's more homogeneous. In second, we have the public transit accessibility, and as expected, we have more accessibility around the areas with more public transit service. Um, we also have that although the transit users and active travelers represent 22.5% of the labor force, they actually can reach only 4% of the jobs available in the study area. So referring to the national survey on transport poverty, we were interested to evaluate perceptions of employment accessibility, and we'll be actually evaluating two questions. The respondents they have to answer to what extent they agree with some statements. We select two of them. So there are too few jobs available for me in my ideal commute time. The respondent have to answer this question use a continuous scale from completely disagree and 100 completely agree. The average response was 58, so people tend to agree with this affirmation. The second case is I have had to decline employment opportunities because of my transport situation. The average response was 41, so people tend to disagree of this affirmation, my sample specifically. What we want to see is the effect of the calculated accessibility that was calculated for the census tract in the perceived accessibility of individual. And then what we did was we categorized the continuum variable related to the perceived accessibility, in which we used a Likert scale, and we categorized each respondent response based on most positive, positive, neutral, negative, and most negative perception using their position in a weighted quintile. In addition to the accessibility variables, we also have variables related to the urban landscape, and we also have social demographic and transport variables at individual level that were obtained from the national survey. For this research specifically, we'll be focusing on the effect of accessibility, the calculated accessibility. And we use weighted ordinal categorical regression to check the effect of calculated accessibility on the perceived accessibility. And to establish causality for the accessibility indicator, we use the two-stage residual inclusion using spatial filters that were created based on the calculated accessibility as instrumental variables. So going to the results, and actually there is a very long table related to the regressions with all the coefficients, but as I explained it, I would like to focus on the calculated accessibility. For the motorizing mode, we see that there is a was not statistically significant for any of the modes. For the active accessibility, we have interesting behavior in which the general effect of active accessibility is negative in a way that increasing active accessibility implies in more negative perception. But when we look specifically for active travelers, or we see the interaction with the type of mode, and for active travelers, the effect is positive in a way that increasing accessibility for a person that is active traveler implies a more positive perception. A slightly positive perception. It's not very, very high, but it's a slightly positive perception. And we also have the public transit effect that is positive for the perception related to there are too few jobs available for me in my ideal commute time. In a way that each additional job that a transit user can access was associated with a 25% increase in the odds of being in a more positive perception. And for the definition and suggestions of standards, we'll be focusing on this effect of the public transit for the perception of there are too few jobs available for me in my ideal commute time. One thing that we can see from this plot is that increasing accessibility, we have more probabilities of having positive perceptions and less probability of having negative perceptions. But this is actually the general effect of accessibility. We also would like to investigate the effect on some specific or some individual profiles. More specifically, on the equity deserving profile that we are creating as the intersection of all populations facing the greatest transportation challenges. And we want to compare this equity deserving group with two other groups, two other profiles. That would be the most common, that is the most common population in the study area, and an advantage profile in which we selected a more privileged segment in terms of the segment of the population, in terms of their transport experience. And if we were to summarize each of these profiles, we could say using income, race, gender, disability, and number of vehicles, we have for the equity deserving group a low income racialized woman with disability and without a car or a bike. For the most common, we have a middle income racialized cisgender man without disability with one car and one bike. And for the advantage profile, we have a high income non-racialized cisgender man without disability and with two cars and one bike. In addition to this, we also identified three thresholds. So the first threshold is the minimum level of accessibility that would result in a higher probability of being in at least in a neutral perception. We identified the progressive threshold that is the minimum level of accessibility that would provide higher probabilities of being at a more positive perception. And between these two, we have the intermediate threshold that is exactly the midpoint between the two accessibility thresholds. Here we can see the effect of increasing accessibility for the advantage profile, for the most common profile, and for the equity deserving. For the advantage profile, we see that even at a minimal level of accessibility or zero level of accessibility, we have high probabilities of being in a neutral to a more positive perception. While this is very different for the most common population and even more for the equity deserving group. For the equity deserving group, only at a level of 0.16, we have that the sum of neutral and positive probabilities being greater than the negative probabilities. And this conservative threshold is also greater than the median accessibility calculated for the study area. For the progressive threshold, we have actually the same level as the maximum observed accessibility in the study area, in a way that at this level we have more positive perceptions probabilities than the probabilities of being in a negative perception. In a way that we can summarize as that for the equity deserving profile, we need more accessibility in order to achieve a neutral to more positive perception. We can take these thresholds and take them as the equity standards, thinking that they are the accessibility thresholds to achieve a more neutral to positive probabilities in terms of perception for the equity deserving profile. In addition to this, we can calculate the accessibility fairness index. That is a population weighted difference between the accessibility of the census tract and the standard that were defined based on the equity deserving profile. We also categorize the census tract between very high, moderate, and low priority for policy intervention. And this is the plot that we have for with the classification of the study area in priority levels and also in terms of the equity standard. Equity standard that were, again, defined based on the equity deserving profile. For the conservative standard, we have that not all actually, most of the census tract without deficit, they are around the city of Toronto. But in fact, we have 68% of the census tract in deficit, and they represent 66% of the population of the study area. The subdivisions with the biggest population in very high priority are first Brampton, then Hamilton, Vaughan, and for the intermediate threshold, we have the majority of them, most of them majority of them are located in downtown Toronto. We have 91% of the census tract in deficit. In terms of population in very high priority, we have the biggest population in very high priority. We have the Brampton, Hamilton again, and now Markham, like passing the subdivision of Vaughan. For the progressive threshold, we have actually only one case of in which we have a census tract with accessibility level greater than the progressive equity standard. And in terms of the subdivisions with the biggest population in very high priority, we have Brampton, Hamilton, but now we have the city of Toronto coming third. But in terms of the share of population, we have 100% of the population of the subdivisions of Williambury, Uxbridge, and Whitchurch, Stouffville. They are living in areas classified as very high priority for policy intervention. To conclude, this was a data-driven example of how transportation planning can support more equitable outcomes. We see this type of study as an early step that should be followed by democratic and participatory decision-making process, where the residents and stakeholders can actively influence the standards that, if adopted, that if adopted, will later on affect their lives. Thank you. This was my presentation.
Thank you so much, Bruno, for your presentation. So let's pause for a quick Q&A session. Does anyone have any question for Bruno? Okay, yeah, so I just have one question. Uh, yeah, you mentioned according to progressive standard, if I recall correctly, only one census tract in Toronto does not have an accessibility deficit. So do you know which area is that?
As it is in actually the neighborhood of the St. George subway, because this station connects the yellow line with the green line, and there is also the Spadina streetcar, like
Mm,
around that area, so provides a lot of um, public transit accessibility.
thank you. That's very informative presentation. So yeah, thank you everyone, especially to our presenters. Steve, do you have anything to add or final
Well,
thought?
actually, yeah, and I wanted to ask Bruno one other question. Bruno, yeah, I'm wondering about um, kind of the value of the regional scale of the analysis that you conducted from the
Yes.
perspective that naturally kind of the 905 area and even kind of the inner 905 and the outer 905. Um, these are places that are going to have like vastly different um, like inherent accessibility levels and probably expectations of transit accessibility as well. And so by putting them all together, um, you're like always going to see the outer suburbs as being the most in need of policy intervention for transit investment. And so, yeah, I'm wondering how you thought about that, whether or not kind of doing the analysis at a municipal scale rather than a regional scale would like complement your results or give you different, more nuanced policy directions away from, suburbs need more, city needs less. There's kind of
Mhm.
a dichotomy that I saw in your maps there.
Yes, I think that when we were calculating, actually defining the study area, we decided to include this sense of these metropolitan areas of Toronto and Hamilton because even in the definition by Statistics Canada of this areas, metropolitan areas, they consider the flow between the cities or the flow between the subdivisions. So we decided to include because even though we also beginning we were trying to use just the city of Toronto, for instance, or just the city of Hamilton. And we believe that when we are actually just selecting a population from a determined, like a specified area, we might be overestimating the accessibility of an area because we are maybe thinking that the jobs that are like from Toronto are, and I can use Toronto because I think it must be the like an important case that the jobs from Toronto they are not accessed only by people from Toronto. So like many people from the other subdivisions are also going there. So we think that this competitive factor and even competition between the different populations in the CMA could be explicative in a way that if we were, probably just pick the population from Toronto, we would be maybe inflating the accessibility levels. Another point is that I tried it for the city of Hamilton, and the result seems to be similar as well. What I did was just like considering the accessibility that was created for the entire region, but just picking the respondent from Hamilton, and the coefficients were similar.
Yeah, it's interesting. So that adds a little bit of confidence for sure. Good. Well, thank you very much, Bruno. And Amir, thank you very much for organizing these sessions, the research sessions this afternoon, and for moderating. I don't have too many formal thoughts to end on, except to say, thank you very much for everyone's participation. I'm pretty sure this was a record-breaking symposium for us in terms of number of attendees. And looking at some statistics that Jasmine's already shared, we had a very consistent level of participation throughout the entire day of around 90 people, obviously some coming in and out. But just shows, I think, the continued relevance of the work, the sustained interest in the project, especially in the national survey. We already have hundreds of users on the who have been digging around on the dashboard since we released it this morning. So just I think, for all of the students who presented work, we're looking forward to seeing these results getting published and sharing policy briefs and kind of summaries for non-academic audiences. And just I feel very enthusiastic about the opportunity that lays ahead in terms of continued use of the survey, continued use of the tools that we're developing for you to use. And our door just remains open for those who want to get involved, figure out what they can do with our data or other resources. We are here to help and promote and support. So I think with that, we'll conclude the day, and big joint round of applause for everybody. And we will see you next time. Thanks, everyone.